In this example, we will learn how to factor the difference of cubes. The sum of cubes is very similar. The algorithm or pattern that you follow is the same. The first thing we have to do is inspect the binomial to make sure it is the difference of two cubes. 16 is not a perfect cube, and 54 is not a perfect cube, so this is not the difference of cubes. However, don't forget the first rule of factoring. You always look first for a greatest common factor in all the terms. And in fact, this does have the greatest common factor 2. When we factor the 2 out of the binomial, we get 2 times 8x to the 6th minus 27. And 8 and 27 are perfect cubes. 8 is equal to 2 to the 3rd power, or 2 cubed. 27 is 3 to the 3rd power, or 3 cubed. And x to the 6th is actually x squared cubed. So all three are perfect cubes, and we can factor this as the difference of cubes. This is where we start studying the algorithm for factoring the difference or sum of cubes. This is something you must memorize. It isn't something that makes sense. You'll have to just memorize it. Difference or sum of two cubes will always factor as a binomial times a trinomial. So we start out with our signs for a binomial and leave space for a trinomial. Remember to bring the 2 down with you. Students have a habit of leaving that 2 behind and intending to put it in at the end of the problem, but then forgetting to bring it along. Now let's build the binomial in our factorization. First, we take the cube root of the first term in our problem. We already said the cube root of 8 is 2. Then the cube root of x to the 6th is x squared. The way we do this is simply to divide the exponent of x to the 6th by 3, giving us x squared. If it doesn't divide by 3, then it's not a perfect cube to begin with and can't be factored. In the binomial, the sign will be the same as it was in our original problem. And the second term in the binomial is the cube root of 27, which is 3. We have completed our binomial in the factorization. Now we need to complete the trinomial. To complete the trinomial, we can completely forget about all the work we've done, because we're going to form the trinomial from our new binomial. The first term in the trinomial will be 2x squared squared. So when we square 2x squared, we get 4x to the 4th. Be sure you know how to do that. The sign in the trinomial, the first sign in the trinomial, will be the opposite of what our binomial has. In this case, it's a plus. The second term in the trinomial is the product of the 2 terms in the binomial. In other words, 3 times 2x squared, or 6x squared. And finally, the third and last term in the trinomial will be the square of the second term in the binomial. In other words, we square 3. And this term will always have a plus sign. So remember, in the binomial, the sign is the same as in the problem. In the trinomial, the first sign is the opposite, and the third sign is always a plus. Watch this video several times until you memorize the procedure. If you're working with the sum of cubes, then the sign in the binomial will be a plus, as in the problem. The first sign in the trinomial will be a minus, the opposite of what's in the problem. And the third term in the trinomial will again always be a plus.